The temperature T in degrees Celsius of a cooling liquid is modelled by the equation T is equal to 34 plus 68 times 0.5 to the 4T, where T is the time in minutes after the cooling begins. What is the initial temperature of the liquid? Find the temperature after 1.5 minutes. How long does it take the temperature for the liquid to be 68 degrees C? And what is the temperature does the model predict the liquid will eventually reach? So we got T is equal to 34 plus 68 times 0.5 to the power of 4T. The initial temperature is when T is equal to 0. So if we substitute that in, we get T is 34 plus 68 times 0.5 to the power of 4 times 0. Anything to the power of 0 is 1. So the initial temperature will be 34 plus 68 times 1, which gives me 102 degrees C. When T is equal to 1.5 minutes, T will be equal to 34 plus 68 times 0.5 to the 4 times 1.5, which gives me 35.1 degrees C. Right, now we need to know when the temperature is going to be 68. So when T is equal to 68, we're going to get 68 is equal to 34 plus 68 times 0.5 to the 4T. If we subtract 34 from both sides, we're going to get that 34 is equal to 68 times 0.5 to the 4T. Now dividing by 68, we're going to get 0.5 is equal to 0.5 to the 4T. Now we could proceed with logarithms here, but it's not necessary, because we have the same base here, same base of 0.5, and therefore if the same base, if we put this here is 0.5 to the 1 must be equivalent to 4T, so 1 must be equal to 4T, therefore T must be equal to 0.25 minutes, and in seconds that would be 15 seconds, because 0.25 times 60 seconds is 1 minute. Okay, now we need to find the temperature which it eventually cools to. So we've got T is equal to 34 plus 68 times 0.5 to the 4T. Now, if we rewrite that as 34 plus 68 times to the half, which is to the 4T, then that is 34 plus 68 times 2 to the minus 4T. That's using the idea that 1 over a to the n is equal to a to the minus n. Now, we've got a exponential decay here because we've got a minus power. So this is exponential decay. So we should be able to draw a graph. Okay, so the initial temperature is 102 degrees C, which is there, and what happens is that this is going to decay exponentially. Now eventually it will get down to this being to 1/2 to the power of infinity, and then 2 to the power of infinity is like 0 times 68 is 0, so it'll actually get down to 34, will become what's known as a horizontal asymptote. Okay, so just to explain that again, if we look at it in this format, as T gets very, very large, this value here will get very, very, very small, and therefore the function will become like 68 times nothing, which is 0, and this will come down to 34. So this is a horizontal asymptote, and therefore T, it will eventually cool down to T being equal to 34 degrees C. Okay, this has been a video to show you how a exponential decay works with a horizontal asymptote. I hope you understand, and I thank you very much for watching.